This is pretty cool. A real-life Dexter's laboratory. Yeah, that's how you say it. A whiz kid with a very powerful idea. Max Laughlin shares his story in tonight's Someone to Know. Do you think a 13-year-old could change the world? Well, this one might change your mind.
I'm here with Max, who's a young inventor. Now, Max, what did you invent?
I invented the EHG, or Energy Horizon Gatherer, and it's an energy initiative to collect cosmic energy.
And how would you explain cosmic energy to someone who's never heard of it before?
Well, simply, cosmic energy is the expansion of space that is reverberated out. So space expands, and as it does, it releases cosmic radiation. When this cosmic radiation hits our atmosphere, it transfers into the ionosphere and sends billions of particles of charged ions, raining down on us in quantities of, billions.
The captivating story of Max Laughlin, a young genius who made a groundbreaking invention and then suddenly disappeared, has left the scientific world stunned over the years. Once celebrated as one of the brightest minds in the world, he vanished without a trace, just as his incredible technology was about to make waves, leaving everyone wondering what happened. Recently, Max has resurfaced, bringing with him a haunting message that could change everything we think we know. What unsettling truths is he ready to reveal? Join us in this video as we dive into the mystery of the world's smartest kid and explore the chilling warning he's returned with. The enigmatic return of Max Laughlin, a journey into parallel universes. Max Laughlin, once hailed as the world's smartest kid, was a child prodigy who captivated audiences with his extraordinary theories and innovative inventions. Born into a family that nurtured his curiosity, Max showed remarkable talent from an early age. While other kids were glued to their video games, he was experimenting with complex scientific concepts, including groundbreaking ideas about CERN and the ambitious creation of free energy. As he grew, Max quickly gained a reputation for his bold ideas that left even seasoned scientists in awe. He was invited to speak at conferences, inspiring a new generation of thinkers with his unfiltered passion for discovery. But just when the world was starting to take notice, Max vanished without a trace, sparking a whirlwind of speculation. Where did he go? Some believed he went into hiding to protect his extraordinary gifts, while others thought he might be delving into secret research in uncharted territories. A more sensational theory suggested he had been kidnapped by powerful organizations eager to exploit his genius. Max's sudden disappearance left behind a legacy of unfinished projects and countless unanswered questions. Then, like a bolt from the blue, Max resurfaced, reigniting the intrigue that had surrounded his life. What secrets did he bring back? Upon his return, he began to share astonishing revelations that raised the stakes even higher. Max claimed that the Large Hadron Collider at CERN posed a grave threat to our reality, issuing bold warnings that captured the attention of experts worldwide. He argued that the high-energy collisions at CERN could create portals to parallel universes, potentially endangering our very existence. Imagine a world where every quantum event splits our reality into parallel branches, leading to an infinite multiverse. This was Max's theory. He believed that every time the LHC conducted an experiment, it could inadvertently open gateways to these alternate realities, allowing us to exist in dimensions we might not even realize were there. Max's insights were not just theoretical musings, they painted a vivid picture of a cosmos brimming with possibilities. He suggested that when things go wrong during LHC experiments, a chain reaction could occur, fracturing reality itself. This could even explain phenomena like the Mandela effect, where groups of people remember events differently. What does this all mean for us? As we delve deeper into Max Laughlin's astonishing journey, we'll explore the implications of his warnings and the mysteries of the universe he sought to unveil. Buckle up for a captivating ride through the realms of existence as we uncover the truth behind Max's extraordinary claims. The Mandela effect and Max Laughlin, unlocking the secrets of parallel realities. Max Laughlin's theories extend beyond mere scientific curiosity. They delve into the very fabric of our reality. One of his most compelling ideas is the connection between CERN's experiments and the phenomenon known as the Mandela effect. But what exactly is the Mandela effect, and how does it challenge our understanding of history? Named after Nelson Mandela, the Mandela effect describes a curious phenomenon where a group of people collectively remembers an event or detail differently from how it's recorded. For example, many remember Mandela dying in prison during the 1980s, despite the fact that he passed away in 2013. This collective misremembering raises fascinating questions about the reliability of our memories and historical records. Max also points to examples like the beloved children's series, The Berenstain Bears, which some insist was once spelled Berenstain Bears. Then there's the oddity surrounding New Zealand, with some recalling it in a completely different location on the world map. These discrepancies serve as more than just fun trivia. They bolster Laughlin's hypothesis that alternate realities might be seeping into our own. Imagine a world where the very nature of our past could be altered due to fluctuations in time and reality. A world where the lines between our memories and the truth blur. Laughlin suggests that these inconsistencies might not just be random errors. Instead, they could be evidence of parallel universes colliding with our own. Each altered memory could represent a glimpse into a reality where things unfolded differently. The implications of Laughlin's insights are staggering. He argues that the Large Hadron Collider, LHC, is not just a scientific marvel. It could be a gateway to these alternate dimensions. With its powerful particle collisions, the LHC has the potential to distort space-time itself. According to Laughlin, even a tiny shift in the behavior of particles, such as an electron, could send ripples through the very fabric of our existence, pushing us into another reality entirely. This notion complicates everything we know about particle physics. It challenges the limits of scientific understanding and suggests that we might be on the brink of discovering a multidimensional universe. Laughlin's theories have ignited imaginations around the world, encouraging people to reconsider what they think they know about reality. But with such bold claims come critical questions. Could it be true? Are we truly living in a reality that can be altered or even replaced? As Laughlin shares his warnings about the LHC and its potential to open gateways to parallel universes, he becomes both a source of fascination and a figure of concern. The idea that our universe might not be the only one, or that it could be altered at any moment, leaves us on the edge of our seats. As we navigate through these profound questions, we're invited to explore the intricate mysteries of existence. Laughlin's theories have sparked imaginations worldwide, reigniting curiosity about the mysteries of the universe while simultaneously raising doubts. Could there be truth to his claims? Should the world take his warnings seriously? As we explore the implications of Laughlin's ideas, we're left pondering the nature of reality itself and the intriguing possibility that our universe is more complex than we could ever imagine. Unraveling the universe, the fascinating journey of CERN's Large Hadron Collider. CERN's Large Hadron Collider, LHC, stands as the largest and most powerful particle accelerator in the world, a remarkable scientific endeavor nestled beneath the picturesque landscape of the French-Swiss border near Geneva. The vision for the LHC took root in the late 1950s, but it wasn't until September 10, 2008, that its complex machinery roared to life, marking a significant milestone in the field of particle physics. Over the next 2 decades, the LHC is scheduled to run with several planned interruptions for essential upgrades and maintenance, ensuring its technology remains at the forefront of scientific research. The LHC has the extraordinary capability to recreate the conditions that existed just a billionth of a second after the Big Bang, providing a unique window into the very origins of our universe. By colliding high-energy subatomic particles at unprecedented speeds within its extensive ring structure, scientists can meticulously observe the interactions that occur. These experiments aim to unlock the mysteries of fundamental forces and particles, contributing to our understanding of the universe's composition. At the heart of these explorations lies the Standard Model of particle physics, a comprehensive theory that emerged in the early 1970s. This model describes the fundamental particles and the interactions that govern them. Remarkably, it has successfully predicted a vast array of phenomena, explaining nearly all experimental results encountered in particle physics up to this point. However, some theorists, including Laughlin, express concerns regarding the implications of these high-energy collisions. They propose that the processes occurring within the LHC might inadvertently disrupt the very fabric of our universe. This raises intriguing questions about the nature of reality itself and the potential consequences of humanity's quest for knowledge. As research continues at the LHC, the intersection of theoretical physics and existential inquiry remains a compelling narrative in the ongoing story of scientific discovery. The Standard Model of particle physics has been a monumental achievement, but it's not without its flaws. It leaves many questions unanswered, especially when it comes to the origin of mass. For instance, it doesn't clarify why some particles are incredibly heavy while others have no mass at all. To tackle this issue, theorists like Robert Brout, Francois Englert, and Peter Higgs propose the Higgs mechanism. This theory suggests that particles gain mass through their interactions with an invisible field, now known as the Higgs field, which fills the universe. Essentially, particles that interact strongly with this field are heavier, while those that interact weakly are lighter. The quest for the Higgs boson, the particle associated with the Higgs field, began in earnest in the late 1980s. What seemed like a straightforward search turned into a decades-long journey across the globe. Finally, in July 2012, data from the LHC confirmed the discovery of the Higgs boson, a moment celebrated as one of the most significant breakthroughs in modern physics. Often referred to as the God particle, the Higgs boson is essential for our understanding of the universe. Without it, particles wouldn't have mass, meaning there would be no stars, no planets, and no life as we know it. But finding the Higgs boson is just the start. Researchers now need to study it further to measure its properties and understand its rarer decay processes. CERN makes it clear that any new theory must be testable. A recent example of this occurred in January 2022, when scientists announced evidence of X particles within the quark-gluon plasma created at the LHC. These X particles are predicted by theories like supersymmetry and extra dimensions and could be unknown components of dark matter or exotic particles that go beyond the Standard Model. For part of each year, the LHC conducts collisions between lead ions, recreating conditions similar to those just after the Big Bang. When these heavy ions collide at high energies, they temporarily form a quark-gluon plasma. Through these experiments, the LHC aims to test theoretical predictions, including the Standard Model, and identify any gaps in our understanding. Interestingly, physicists are eager to find these gaps, as they could hold the key to explaining phenomena like dark matter and dark energy, which remain one of the biggest mysteries in modern science. The matter we know, everything that makes up stars, galaxies, and planets, accounts for only about 4% of the universe. This leaves a huge mystery that has puzzled scientists for decades. What makes up the remaining 23% of dark matter and 73% of dark energy? Understanding dark matter is one of the biggest challenges in modern physics. While researchers believe that dark matter constitutes most of the universe, its exact nature remains unknown. The Large Hadron Collider, LHC, is a remarkable scientific achievement designed to tackle these mysteries. By generating powerful particle collisions, it serves as a key tool for studying dark matter. Another intriguing question in cosmology is the puzzling imbalance between matter and antimatter. According to the Big Bang theory, the universe should have started with equal amounts of both, yet almost all antimatter disappeared shortly after the Big Bang, leaving behind the ordinary matter we see today. This phenomenon, known as CP violation, is one of the main focuses of the LHC's experiments. as understanding it is essential for grasping our existence and the universe we inhabit. However, some young theorists, like Max Laughlin, have raised concerns about the safety of these complex experiments, warning of potential dangers in the future. Since its establishment, CERN has faced numerous controversies and ominous speculations, especially after the LHC began operating. Despite the organization's efforts to reassure the public, fears have emerged about the possibility of creating black holes. Some scientists speculate that missing energy could point to extra dimensions, and one proposed method to explore this is through the creation of microscopic black holes. Many worry that the high-energy collisions at CERN could lead to tiny black holes that might pose a threat to Earth. Recently, rumors have circulated about a quantum black hole potentially forming near Geneva, with some claiming it could cause Europe to vanish instantly. Yet, physicists argue that these experiments follow strict safety protocols. They maintain that any black holes created would be tiny and short-lived, disintegrating in about /10 circumflex minus 27 seconds, and therefore would pose no real danger. Still, concerns about the LHC's impact on the Earth's magnetic field have arisen, with discussions about a possible complete shift in this field. The LHC relies heavily on powerful magnetic fields to accelerate and steer particles, leading to criticisms regarding its potential contribution to carbon emissions and environmental strain. As speculation grows, questions about how such experiments might affect the Earth's magnetic field and the larger cosmic environment have prompted a thorough review of CERN's safety measures. Despite these challenges, CERN remains optimistic, hoping to gather significant data and make groundbreaking discoveries by 2025. Their commitment to understanding the universe reflects a dedication to advancing knowledge, even amidst external pressures. At the same time, public backlash continues, with many people finding new reasons to support Max Laughlin's views. This raises an interesting question. What authority does a young theorist have compared to seasoned physicists and scientists? Why should the world listen to a child over experienced professionals? The debate continues, highlighting the delicate balance between scientific progress and public perception. Max Laughlin, the prodigy, redefining possibilities in science. To earn the title of the smartest kid in the world, one must achieve something truly extraordinary, and Max Laughlin certainly embodies that distinction. His incredible journey began at a young age, leaving an indelible mark on the world of science, particularly through his audacious challenges to CERN and his groundbreaking innovations. From the very beginning, Max showed an insatiable curiosity and a deep passion for unraveling the mysteries of physics. While most children were playing games, he was grappling with complex scientific concepts that would leave many adults scratching their heads. By the time he was just 13, he had already made waves in the scientific community with his invention of a revolutionary free energy device. Think of a machine that could provide clean, limitless energy for the entire planet. This isn't just a dream, it's a vision that Max made a reality. His invention has the potential to completely transform how we consume energy, leading to a future where sustainable living is not just possible, but practical. This free energy machine stands as a beacon of hope, illuminating the path toward a greener tomorrow and showcasing the boundless potential of young innovators. It's a crowning achievement in Max's remarkable story. Max's invention didn't just capture the attention of scientists, it ignited the imagination of the public, resonating with our collective aspirations for a brighter future. His work reignited a passion for science, inspiring a new wave of thinkers and dreamers. After his invention took off, Max became a household name, and his fame soared even higher as he began sharing his insights into the wonders of the universe. His exceptional grasp of physics secured him a spot at the University of Wisconsin-Madison, where he dedicated himself to physics engineering, eager to contribute to breakthroughs in renewable energy. Max's journey has been nothing short of extraordinary. He has delved into the realms of particle physics, renewable energy, and even crafted 3D models of ancient petroglyphs at Valley of Fire State Park. His theories about parallel universes and shared memories, along with his captivating speculations regarding CERN's possible ties to the Mandela effect, have sparked vibrant debates within the scientific community about the very nature of reality. The concept of the multiverse has fascinated scientists for decades. Unlike the fantastical portrayals often seen in science fiction, this idea offers a legitimate theoretical framework in cosmology and quantum physics to explain phenomena that current theories can't fully address. It suggests that realms beyond our observable universe may exist, and Max's innovative approach sheds light on these mysterious dimensions and their potential connections to our own reality. According to multiverse theory, every possible outcome of a quantum event unfolds in its own unique universe, creating an infinite tapestry of parallel worlds. This means that quantum particles, such as electrons, can exist in multiple states at once, with each possibility playing out in a different universe. Physicist Sean Carroll emphasizes that human choices don't directly cause the creation of these alternate realities. Instead, they exist independently, triggered by quantum events rather than our actions. This perspective draws a fascinating analogy between our lives in the multiverse and the paths of identical twins who share similar histories but diverge into distinct journeys. Exploring the multiverse invites profound philosophical and psychological questions, offering a fresh lens to examine the impact of our choices. Yet, it's essential to remain anchored in our reality, where our actions have real consequences. Venturing into the multiverse can yield valuable insights, as evidenced by Max's theories and ongoing experiments at CERN. CERN's groundbreaking research, including major upgrades to the Large Hadron Collider, continues to push the frontiers of our understanding of the universe, inspiring awe at its complexity and sheer scale. Max Laughlin's theories, when intertwined with CERN's discoveries, encourage us to contemplate the vastness of the cosmos and the intricate web of possibilities it presents. Although his unexpected absence has left a gap in the scientific community, his story represents the relentless pursuit of knowledge and a profound connection to our world. As Max continues on his journey, there's a renewed buzz of excitement about the potential scientific breakthroughs he might unveil. Many are hopeful for discoveries that could transform our understanding of reality and benefit humanity. Max Laughlin's theories and CERN's findings challenge our perceptions of the universe and the myriad secrets it still holds. His story is not just one of a brilliant young mind, it's a testament to a new era of scientific exploration, where the boundaries of knowledge are continually expanded and the possibilities are truly limitless. Could our understanding of the universe and our place within it be even more intricate than we imagine? What fascinating mysteries might we uncover as we dive deeper into the cosmos? Share your thoughts in the comments below. If you enjoyed this video, don't forget to like, share, and subscribe to our channel for more amazing content.